Hello, I'm meteorologist Kyle Perez with the National Weather Service in Springfield, Missouri. On today's Weather Unlocked video series, we will be taking a look at lightning, how lightning develops, the different types of lightning, and ways to stay safe with lightning. Taking a look at a lightning climatology across the United States, you can see that portions of the Gulf Coast into the southern plains are the highest areas of lightning strikes per year. However, we are no stranger to thunderstorms and lightning across portions of Missouri as well. As you can see, that it's denoted by the dark shade of purple and the lighter blue colors that are in across portions of our area. Additionally, weather-related fatalities with respect to lightning continue to be on the decline each year, but are still a concerning number. The 10-year average is 23. Meanwhile, the 30-year average is closer to 37. So while that number has come down over the past several years, it continues to be an area of concern related to weather-related fatalities. So let's discuss how lightning develops. Taking a look at the different diagrams here, the one on the left shows you a schematic diagram of different liquid drops, supercooled drops, and grapple and ice crystals within a developing thunderstorm. On the right-hand side, this is what it would look like with different ice crystals and molecules crossing each other's paths and colliding, a process that will be important in the development of lightning. So what exactly is the process that occurs? So what happens is the updrafts transport the small liquid water drops from the lower regions of the storm to heights well above the freezing level. As this occurs, downdrafts then transport hail and ice from the frozen upper regions of the storm, which then collide with the water droplets and freeze and release heat. This heat, in turn, keeps the surface of the hail and ice slightly warmer than the surrounding environment, and a soft hail known as grapple forms. When this grapple collides with additional water droplets and ice particles, a critical phenomenon occurs, where electrons are sheared off of the ascending particles and collect on the descending particles. Because electrons carry a negative charge, the result is a storm cloud with a negatively charged base and a positively charged top. Here's another way to look at how lightning and the different charges develop between the cloud and the ground. The first stage being that thunderstorms gather in a pool of positively charged particles, and the negatively charged area in the storm will send out a charge towards the ground. Notice the difference between the negative charges denoted in the black and the positive charges denoted in red near the ground and as well as the upper region of the thunderstorm. A channel then develops between these two, resulting in the release of lightning and development of lightning. A quick fact here is that lightning can be as hot as 54,000 degrees, a temperature that is 5 times hotter than the surface of the sun. When lightning occurs, it heats the air surrounding its channel to the same incredible temperature in a fraction of a second. The example shown on this graphic is at a negative cloud-to-ground lightning strike. Coming up in the next few slides, you will also find out that there is also positive cloud-to-ground lightning strikes. So what are the differences between negative lightning strikes and positive lightning strikes? On the left-hand side, you can see that a negative lightning strike is a transfer of negative charge from the cloud to the ground, and the cloud-ground streamer will have a positive charge. And it accounts for the majority of lightning strikes within a thunderstorm, but has weaker electric fields. On the other end, you have positive lightning strikes that transfer positive charge from the cloud to the ground. Typically, the ground streamer will have a negative charge, but it only accounts for less than 5% of all lightning strikes, but has a much stronger electric field. So now we will take a look at the different types of lightning. There's cloud to ground. There's intra-cloud, which occurs within the cloud itself. There's cloud to air, where it goes from the cloud simply to something in the air, different charges. And lastly, there is cloud to cloud. So what are the different ways you can be struck by lightning? In this particular slide, we will go over the different ways that you can be struck by lightning. First, there is a direct strike. This occurs when a person is struck directly by lightning and becomes part of the main lightning discharge channel. Most often, direct strikes occur to victims who are in open areas. The next way to be struck by lightning is a side flash. A side flash occurs when lightning strikes a taller object near the victim, in this example a tree, and a portion of the current jumps from a taller object to the victim. The next example is a ground current. This occurs when lightning strikes a tree, as seen in this example, or another object. Much of this energy then travels outward from the strike in and along the ground surface. This is known as the ground current. Anyone outside near a lightning strike is potentially a victim to a ground current. The fourth way of being struck by lightning is by conduction. Conduction struck by lightning can travel long distances in wires or metal fences. Metal does not attract lightning, but it does provide a path for lightning to follow. And lastly, you can be struck by streamers. Streamers develop as the downward moving leader approaches the ground. Typically, only one of the streamers make contact with the leader as it approaches the ground and provides the path for brighter return stroke. However, when the main channel discharges, so does all the other streamers in the area. So when you think of lightning, you also think of thunder. So what exactly is thunder? Here are all the different ways of looking at thunder and how it occurs. And as you can see, as thunder is simply the sound caused by a nearby flash of lightning and can be heard for a distance of anywhere from nearby to up to 10 to 25 miles away from the actual lightning strike. The sound of thunder should serve as a warning to anyone outside that they are within striking distance of the storm and need to take shelter immediately. So thunder is simply created by lightning passing through the air. When that lightning discharges heat that rapidly expands, the temperature of the air in the lightning channel then reaches temperatures of upwards of 54,000 degrees Fahrenheit. And immediately after that flash, the air cools and contracts quickly. This rapid expansion and contraction then creates the sound wave that we know as thunder. So let's take a look at some lightning quick facts. All thunderstorms produce lightning and are dangerous. Lightning kills more people each year than tornadoes and hurricanes combined. Additionally, lightning can strike more than 25 miles away from rainfall. As a result, many deaths occur from lightning ahead of the storm because people wait until the last minute to seek shelter. Lightning can also strike well beyond the audible range of thunder. However, if you hear thunder, this means the thunderstorm is close enough that the lightning could strike your location at any moment. Lightning can result in injuries that lead to permanent disabilities or even death. On average, 20% of strike victims die. 70% of survivors suffer serious long-term effects. Another quick way to analyze the lightning threat is to look for dark cloud bases and increasing wind with a thunderstorm as it's approaching. Every flash of lightning is dangerous, even the first. Head to safety before the first flash. If you hear thunder, head to safety immediately. And lastly, no place outdoor is safe during a thunderstorm. If lightning is seen or thunder is heard, or if dark clouds and thunderstorms are beginning to develop in your area, quickly move indoors into a hardtopped vehicle and remain there until 30 minutes after the final clap of thunder. Make sure you follow the NWS and other weather resources and that there is no longer immediate threat for lightning in your area. Some lightning safety tips to keep in mind. Your chance of being struck by lightning greatly increases when remaining outdoors during a thunderstorm. This includes many outdoor activities such as golfing, boating, running, even other things such as gardening, grilling, walking. And lastly, you want to avoid areas where you may be swimming, such as lakes, rivers, streams, or pools. Some lightning safety tips to keep in mind: when thunder roars, go indoors. Additionally, see a flash, dash inside. We encourage everyone to become a Weather Ready Nation ambassador. And make sure that you continue to follow the Weather Unlocked video series for additional educational videos on various weather topics. Thank you.